Hello students, today in this class we are going to understand determination of internal resistance of a cell using potentiometer. In our classroom we have learned what is potentiometer and how it works. This device usually measures the EMF of a cell. Now to understand it, let me draw the circuit diagram. In the circuit diagram I will explain each component clearly. So E1 is the cell which will flow the current in the whole circuit. E1 is the battery. A is the ammeter which will measure the current in this circuit. RH is the rheostat which can control the current. K1 is the key. PQ is the resistance wire made up of manganese or constant N. From point P, a cell we have connected whose EMF is E. It was connected with a galvanometer and a jockey. This is the resistance R connected with another key K2 to the other end of the cell. Now in this condition, let me draw the circuit again. So here we will use the principle of potentiometer, which is V proportional to L. Now connecting this K1, what we will get? Let connecting this K1 key at this stage, the potential difference across Pj, potential difference across Pj is equal to the EMF of this cell, which is E. Sorry. So potential difference of this Pj across this Pj is equal to EMF E. So we can write, if Pj equals to L1, that length is L1, let us take, then E equals to V Pj, which is the potential difference across Pj, which is proportional to L1. Now E equals to KL1, where K is a constant, you know. This is our equation number 1. Now connecting K2 key also. In this case, we have connected the resistance R in the circuit. In this case, our balance point also will change. Let us take it is at J prime. Now in this condition, here we have connected the resistance with the cell. So here terminal potential difference of the cell will be equal to the potential difference across Pj dash. Listen carefully. So the terminal potential difference, why? Because here the resistance is connected with the cell. Now in this situation we will get, if Pj dash is equals to L2, the length is L2, then V equals to Pj dash proportional to L2. Now V equals to K is the constant multiplied with L2. This is equation number 2. Now dividing equation 1 by equation 2, we will get E by V equals to KL1 by KL2. That is KK will cancel out and then we will get L1 by L2. Take it as our equation number 3. Now this E by V, which is L1 by L2, we will use in our internal resistance equation. So we know that internal resistance of a cell R is equals to E by V minus 1 multiplied with R. So this R is this resistance which we have connected with our cell, and EV is here EV, which is L1 by L2. So here, using equation 3, we get R equals to, instead of E by V I can write L1 by L2 minus 1. So R equal to L1 by L2 minus 1 multiplied with R. So this small r is the internal resistance, capital R is the resistance which we have connected parallelly with our cell. So R is equal to L1 minus L2 by L2 multiplied with capital R. This is the final result which we are searching for. So here, if we know length L1, length L2 and the resistance R which we will get from the resistance box, we can easily find out the internal resistance. Now, as we have understood how to calculate internal resistance, here we will solve a problem where the driving cell's battery is 1.5 volt and the cell voltage is 1.2 volt. The resistance we have connected with this cell is 10 ohm. Let us do it. In this case, 1.5 volt is the driving battery, 1.2 volt is the cell's EMF, and 10 ohm is the resistance connected with the cell. So let me draw. Without connecting 10 ohm, we are getting the balancing point at 65 centimeters. So this PJ distance is 65 centimeter when 10 ohm was not connected, and connecting 10 ohm, the balance point changes to 55 centimeters. Calculate the internal resistance R of the cell. Now to find out the internal resistance of this cell, how we have to perform it? Here the resistance R is equal to 10 ohm. Without connecting this resistance, the balancing point we are getting at 65, and connecting the resistance we are getting at 55 centimeter. We need to find out R, small r, the internal resistance of the cell. We know R equal to L1 minus L2 by L2 multiplied with the capital R. Therefore, R equals to 65 minus 55 divided by 55 multiplied with 10 ohm. So if you calculate it, you will get the internal resistance of the cell, which is 65 minus 55, 10 multiplied with this 10 divided by 55 ohm. So 100 divided by 55, which we will get if we divide it, that is not to 1.82 ohm. This is the final result. So we have learned how to calculate the internal resistance of a cell. Thank you so much, students.